Hello everyone, this is Ashoke, your personal guide and mentor. I welcome everyone to my YouTube channel AKB Tutorials. Here we are going to discuss and cover some important concepts of mechanical engineering that are very useful and helpful for competitive exam and job interviews. So let us start today's session. Today we are going to learn one of the most important and fundamental topic of basic engineering, that is related to mechanical and civil engineering. Okay, a lot of question is asked from this topic. So today we will start with this topic, that is stress, strain and strength. So students are not able to answer what is the difference between the stress and strength. So in today's video we are going to learn what is the exact difference between the stress and strength. Though it is the most fundamental, but it is most important for any competitive exam. So let us start with today's topic. Consider a body is under load. So say P is the load acting over a body. So because of load P, the body will deform by some amount. So this is the topic of strength of material. So in strength of material, however small may be the force, when it is applied over a body, some deformation will produce in the body. So deformation may be very small, but there should be some deformation. So if you compare these two subjects, the first subject is strength of material and the other subject is engineering mechanics. So if you compare these two subjects, the basic difference or the main concept behind these two subjects are: in strength of material, the load may be very small, but there should be some deformation. So there should be some deformation in strength of material. But if you consider this subject, the main concept behind this subject is, if the load becomes very high, then also the deformation produced in the body is zero. That is, in engineering mechanics, the body is considered as a rigid body. So what is rigid body? Now the body in which, if the load applied on it, the deformation produced in the body will be zero. So in engineering mechanics, we have considered the body as a rigid body and the deformation produced in the body is equal to zero. And in case of strength of material, so the load may be very small, then also there will be some deformation. So this is the main difference between the two subjects. Now load is applied over a body. Say body is of arbitrary shape. If we consider, say this is a body, the body is under load P is acting over a body. So load P is acting over a body. So now let the cross sectional area on which the load P is acting, it is given by or denoted by A. The area on which the total load is acting is A. Then what is the stress? The definition of the stress, it is the resistance developed in the body per unit cross sectional area. So that means, so if a body, this is a body, okay, if this body is under load P, that P is the externally applied load. When P load is applied over a body, an equal and opposite amount of resistance is developed in the body. So this is our resistance developed in the body, and this is called the externally applied load. Load. So as soon as we apply a load, external load P, an equal and opposite amount of resistance developed in the body. So the resistance developed in the body is also P, and the stress, it is defined as the resistance developed in the body per unit cross sectional area, or mathematically, okay, the resistance developed in a body per unit cross sectional area, per unit cross sectional area is known as stress, is known as stress. It is denoted by term sigma. So it is denoted by sigma. So therefore mathematically we can write sigma is equal to P by A. That is, what is P? P is the resistance developed in the body. So resistance developed in the body per unit cross sectional area is called stress. So here, due to externally applied load, due to externally applied load, okay, so I hope that definition of stress is clear. The resistance developed in a body per unit cross sectional area is known as stress. It is denoted by sigma due to externally applied load. Okay, so sigma is given by P by A, where P is the resistance developed in the body and A is the cross sectional area. Cross sectional area. So this area may be rectangular, area may be square, cross sectional area, it may be circular, it may be hollow circular, etc. So whatever may be, so the resistance developed in a body per unit cross sectional area due to externally applied load. So that means sigma is given by P by A. The magnitude of sigma. What is the magnitude of stress? So that depends on the magnitude of P. So if P increases, stress value will also increase, and if P decreases, stress value will decrease. So that means stress value will vary from minimum to some maximum value. Some maximum value means if we carry on increasing this P value, a certain point will come where the body will fail. So that will be the maximum stress we can apply over the body. Okay. So classification, now we will go. What is the unit of stress? Unit. So if we P is given by Newton and A is in meter square. So Newton per meter square. Sometimes in a bigger unit it can be given kilonewton per meter square, or sometimes it can be given meganewton per meter square. So like this we can express the stress in different units. So kilonewton means 1000 Newton per meter square. Meganewton means 10 to the power 6 Newton per meter square. Similarly, giganewton per meter square or 10 to the power 9 Newton per meter square. Now the next point is coming, and frequently it is asked in the course exams, whether stress is a scalar quantity or vector quantity. Here P is a vector quantity, area, so it should be a vector quantity, but no. So sigma means stress is a tensor quantity. Tensor quantity. It is not a vector quantity or a scalar quantity. What is actually exactly a tensor quantity? A tensor quantity, the quantity which can be expressed by three parameters. One is the magnitude, direction, and the area of application. That quantities are called tensor quantities. Okay, we will discuss in another video what is tensor quantity. The quantity, so just remember that stress is a tensor quantity. It is not a vector quantity or a scalar quantity. Now we will see the classification of stresses. Classification of stresses. So now in this we will see the types of stresses. The stresses are classified as tensile stress. First kind of stress is the tensile stress. If the tensile load is applied over a body, the body will increase in size because of this external load. If the external load is tensile, then the body will extend or increase in length because of this application of load. Say dl is the change in length, and the original length is given by L or L0. Okay, so what is tensile stress? The stress caused due to tensile load is called tensile stress. So before that we should know what is tensile load. The load which extend the body. So that means when the load is applied over a body, if the extension of body takes place, then the kind of load is called tensile load. And when tensile load is applied over a body, then the kind of stress developed in the body is called tensile stress, and it is considered as positive. Anyhow, so the stress caused due to tensile load is known as tensile stress. Okay, now the second kind of stress is compressive stress. So what is compressive stress? When the load applied over a body is compressive, then the body will compress, that is compression of the body will take place because of compressive load, then the kind of stress developed in the body is called compressive stress. Suppose the load is applied in this direction, say P is the load is a compressive load over the body. So when compressive load is acting over a body, the compression of the body or size of the body will decrease. So the original size of the body is L0 and say dl amount will decrease because of load P. So if the load causes the compression of the body or the member, then the stress developed in the body is called compressive stress. The stress produced in the body due to compressive load is known as compressive stress. Okay, so this kind of load, that is compressive load, will compress the body or body will decrease in size because of compressive load, and that stress which is developed in the body is called compressive stress. Now these two stress together is called direct stress. These are together known as direct stress. Direct stress. What is direct stress? When the load is applied, whether it is a tensile load or compressive load, it is applied along the axis of the body. Along the axis of the body, load is acting. If the load is acting along the axis of the body, then the kind of stress developed in the body is known as direct stress. So direct stress may be tensile stress or compressive stress. Because of tensile stress, the body will elongate, and because of compressive stress, the body will compress in size. And because of this, direct stress will cause linear deformation. Linear deformation. But in case of shear stress, the body will change its shape, or in other words we can say the angular deformation of the body will take place. So it is shown like this. Say before application of the load, the body is like this. So if we apply the load here, say P is the shear load. Because of P by A is equal to the shear stress developed in the body, and because of shear stress, the body will change its shape, or in other words we can say the angular deformation, and this phi is the angular deformation. Say this one is dl from here to here, and this is denoted by L. So tan phi we can write is equal to dl by L. In a material body, phi should be very small, otherwise the body will fail. So that's why, because of small value of phi, we can write tan phi is equal to dl by L, and this phi is known as shear stress. Okay, so because of direct stress, linear deformation will take place, and because of shear stress, angular deformation will take place. That's all for today's session. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.